Okay, so today we're going to talk about quadratic functions. We're going to talk about key features of quadratic functions. And then we're going to look at the parent function of quadratic. And if we have time, which I'm hoping that we do, we're going to look at change in the quadratic relation if I have a value of a. So the first thing that we're going to identify, which we talked about this yesterday, is that the quadratic relation, which has a degree of 2, is modeled by a smooth symmetrical curve known as a, what do we call the shape of the quadratic? Parabola. If you look at a quadratic function, it's a smooth line, right? So there is no, right? There's bumps or anything. It's a smooth line, and it's symmetrical. Symmetrical means I can cut it in half, and there is a symmetrical, they're symmetrical. Both halves are symmetrical, right? So if you look at this here, if I actually cut it in the middle right here, I can actually, they match, right? The left side and the right side, they match, and that's why we call it symmetrical graph. And then we call this shape a parabola shape. The features that we're going to look at, and we're going to have to know how to identify these features, we start with the zeros. Okay? There's multiple names for the zeros. Okay? So they ask you to find the zeros. They ask you to find the x-intercept. Or they could ask you to find the roots. This is another name for it. They could ask you to solve. Okay? So if they're asking you to find any of this, they're asking you for the zeros. Okay? So if you're going to locate the zeros here, where would you say the zeros are? At the x-axis, right? Because it's the x-intercept as well. So my zeros are right here. How many zeros do you see here? 2. A quadratic can have either 2 zeros, that's the maximum number of zeros that it can have. It can have 1 zero, or it can have no zeros at all. Okay? So if I have a parabola that looks like this, for example, right? You only have 1 0. Right? You see how the graph only intersects the x-axis once? Okay? Then if you have a graph that looks like this, how many times would this intersect the x-axis? None. Yeah, it doesn't have any x-intercepts, right? So the maximum number of x-intercepts you can have is 2. The minimum number you can have is 0. Okay, so you can have 2, 1, or 0 x-intercepts. Are we okay with that? Now, how do I write the x-intercepts? So to write the x-intercepts, you're going to have to, notation here is very important, and I'll be putting the marks on the notation. Okay, not only on the value, but also on the notation. So there's 2 ways that you can write this. You can write it as x-intercept equals 2, or x equals 2. This is -1, and this is, looks like 4. Okay, you can say x-intercept equals -1 and 4. You see how I put x-intercept equal to? You have to have that. And you have to have and 4. Okay? Or the other way to write this is you can write it as 2 points. Okay? If you're looking at the first point, what would you say this point is? What's the x value of this point? What's the y value of this point? What's the y value of this point? 0. Okay? So you can write it as a point. And what would be the second point? 4. What's the x value? What's the y value? 0. That's why they're called the zeros. Okay? Because the y value is a 0. So you write the x value, which is your x-intercept, and then your y value is 0 for x-intercept. Okay? So you have to pick one of the ways to if I ask you for the zeros or the x-intercept, you pick one of the ways. You either write it as x-intercept equal -1 and 4, or you write it as -1, 0, and 4, 0. Okay? Did I put these in bracket, the -1 and 4, did I put them in bracket like this? Are you supposed to put them in bracket? No. Okay? No brackets around these. These are not points. These are values. Okay? When I wrote it in points, I put the brackets. Okay? So the description for this, they're the x-intercept. So it's where the graph intersect or crosses the x-axis. Okay? How about the y-intercept? How many y-intercepts do you see in this graph? How many y-intercepts? Where's your y-axis? X, and this is your y, right? So if you're looking at your graph, where is it intersecting the y-axis? At the -4. So it's right here. Okay? So your y-intercept is right here. And then you can write it as y-intercept equal to -4. Or you can write it as a point, right? So what would this point be? What's the x value? 0. What's the y value? -4. Okay? So you pick one of the notation. Every single quadratic has a y-intercept. Okay? Sometimes it's not visible, but they do have a y-intercept. So it's where the graph crosses the y-axis. Are we okay with this? Are we good with that? Okay, then we're going to look at what we call the vertex. Do you guys know where the vertex is? Yes. Where?
At the tip of the point.
The tip of, it's either the tip of the mountain or the parabola, or it's at the bottom of the parabola, right? So the vertex is your minimum or your maximum point on your graph. So it depends if your graph opens up or if your graph opens down. Okay? So we call this, in this case, it's a minimum. In the other case, it's a maximum. So it's the lowest or highest point. A vertex is a point, right? So you must have x and y value for it. Okay? So if I look at this point right here, can you tell me what that point is? So what's the x value? Let's zoom. Okay. So what's the x value here? The x. The x is 1, and the y is, it's not 6, it's -6. So your vertex is 1 and -6. The vertex is written as a point. Okay. And this is also 1 and -6. Okay? So if I'm going to write this as a general format, and then later on you'll know why I'm writing it as these letters, okay? Later on when we do our other lessons, you'll know why I'm using these points. But we usually represent the vertex as h, comma, k, where h is your x value and k is your y value. And as I said, you will know why we're using h and k as letters. Why does this not want to close? Okay, so you're looking at either your lowest or your highest point of the graph. Are we okay with this? All right. Now, axis of symmetry. So if you're going to draw an axis of symmetry here, a line of symmetry, where would you draw it? So you draw it vertically, going down in the middle, which is going to have to go almost, not almost, it's going to have to go down here, right? Yes? That's your axis of symmetry. Good. So that axis of symmetry passes through what value? Passes through the value 1. And what point does it pass through? The vertex, right? You see that axis of symmetry only passes through that vertex, right? So the axis of symmetry is a line. It's a vertical line, okay? So how do we write the axis of symmetry? We write it as, so the axis of symmetry, this is the short form of it, is at x equals 1. You see my notation here? X equals to 1. I'm looking for that x equals to. Okay? So if you're looking at your vertex here is 1 and negative 6. So is there any match between the vertex and the axis of symmetry? What is it? The x-axis. So that means the x value. So that means the axis of symmetry is the same thing as the x value of your vertex. Okay? The axis of symmetry is the same value as the x value of your vertex. I don't know if you can read this. Right? They match. So the axis of symmetry is an imaginary line of symmetry that runs vertically through the vertex. Okay? So if I'm going to write it in terms of a variable, right? If I look at my vertex is h and k. What would be the axis of symmetry equal to? If I'm using the letters here, what would the axis of symmetry equal to? If I'm using the letter, so my vertex is h and k. Okay? So that means the axis of symmetry is x equals h, because it matches the x value of the vertex. Okay? So this is your general form. This is going to kill me. Are we okay with this so far? Okay, so the last thing that we're going to talk about is what we call the optimal value. Okay, so value, that means it's either your highest maximum or your minimum value on the graph. Okay, so optimal means either max or min. It could be either or. Okay, when I'm talking about the optimal value, I'm talking about the y value. Okay, so what's your minimum y value that you get in this graph? What do we call this a minimum, right? And what's your minimum y value? -6. Okay, so your optimal value here is y equal -6. That's my optimal value. See that in this case, I used the letter y. Right? In the case of the axis of symmetry, I used x. How about your optimal value here? Is it a max or a min? So it's a max at y equals, what's the value here? -6 as well. Okay? So it depends. If your graph opens down, it's a max. If your graph opens up, it's a min. I'm just going to zoom out for a second, and I'm going to ask you, if you're looking at your vertex, which we looked at right here, what part of the vertex does the optimal value match? Does it match the x or does it match the y? The y. Right? So if you look at the vertex is made up of two things. It's made out of the axis of symmetry, that's your x, and then it's made out of the optimal value, and that is your y. So vertex come from two values. The first one is your axis of symmetry. The second one is your optimal value. Okay? So if I'm going to so it matches the y value of the vertex. Okay? Can you guys read this? So, it's how high or low the vertex reaches in terms of the y value. It will be a min when the parabola opens up, and it will be a max when the parabola opens down. Okay? Are we okay with this? So in general, if I'm looking at the general vertex, okay, so I'm just going to zoom out. So your vertex is H and K, right? We said that the H is the axis of symmetry. How about the K? What do we call the K then? It's the optimal value, right? So that means your optimal value is when y equals to the k, right? That's in general, right? H and k, they represent the vertex. H is your axis of symmetry. K is your optimal value. You'll know why I'm using H and k later on, okay? I'll refer back to this. So remember,